Very good morning, students. In the previous class, we discussed about lenses and types of lenses, and in that also again the types are there. I was given very clear information related to the lenses and for the radius of curvatures as well as the focal points, which is finished. And once again I will recall you. See, for the lenses we have two radius of curvatures and two focal points. In case of a convex lens, the focal point will be real and we should consider only second focal point. And in case of a convex lens, a concave lens, there also two focal points are there, and there also we should consider only f2, that is second focal point, and that is in case of a concave lens, that we can also call divergent lens. And here for that focal point we can take as a virtual focal point. And as well as the sign conventions also we finished in the previous class. You go through that sign conventions and it is help you in the problems also. For the calculation, next part also it is very important. Let now today's class I will tell you about a rules for formation of images. First of all we will go for the convex, or we can also call convergent lens. Why convergent? Because the rays were converges from the object. In case of another lens, concave, that we can call divergent, because the rays were diverges from the object. Clear? Now first rule I am telling in case of a convex or convergent lens. So in this case, if the object is, suppose you say at a focal point, therefore the image will be formed at an infinite. It is object is at a focal point, therefore the rays are passes through the principal focus for convex lens and appear to diverge from the focus point. Clear? Now coming to this is the first case, in case of this, and you take a second one also. Suppose in this case you take this is the focal point, no? So that here you take object is at a point is a focal point, therefore the rays were goes like this. See, which is propagated, and the image will be forms at an infinite. Image is at an infinite. It is the first case. See, the image will be forms. And coming to the next point, suppose you take if the rays is passes through the center, optic center. See, it is an optic center. Therefore, that does not refraction takes place. This we can call no refraction. No refraction is taken. No refraction is taken. See, this is related to convex or a convergent lens. See, this is when the object is at a focal point, therefore the image will be formed at infinite. If the object is at a second focal point, also image is formed at an infinite. If the rays were goes along the optic center, therefore there is no refraction is taken, and which propagated like a straight line through the optic center. Like in the same way, I will give you, it is a convex, no, and you go for the concave, or which we can also call it is a divergent lens. Concave, or we can call divergent lens. See, divergent and it is a concave. You take a same thing, same issue. See, this is the concave. Suppose the first one is, you say there is an optic, I mean to say it is a f2 focal point. If the object is like this, therefore there will be image will be forms at an infinite. You say like this, right? So the image will be formed at an infinite. It is an object position and the image will be formed at an infinite. So this is the first case. If you take a same issue here also, whatever here it is there in the above, you take same thing. So suppose it is an A at this point, therefore you take a same like it is a rays were goes opposite to the rays, opposite to the dirt, therefore the image will be, it is forms like it is. You take a dotted lines. Clear? So there it is to be goes like this, and the image will be forms to be like this. So which are very important in case of a divergent lens. And here no refraction case also you take. If the light were goes along the optic center, if it is propagated like this, in this case also no refraction is taken. In this also no refraction is taken. This is actually rules. There are some rules are there like this, right? So this, if we know this, then next rules also is there. I will tell you next rules. So the formation of images. If the object is at a different places, if the object is at different places, therefore we have the formation of images. So it is a one. If the object is at a focal point, the image will be like this. And here there is no refraction case will be. If the ray work goes along the optic center, therefore the light is not refracted. There is no refraction takes place. No. Let us, I'll tell you other also related to the formation of images. If I tell one lens, then the other lens also it is to be applicable. Clear? Let us will go for the rules. Right. See, first one you take a convex or a divergent lens. Again here also same thing, same issue. See, let us go for the first one. See, I'll give you one like here I'll give the diagrams related to formation of images. See, position of object. You take like this, position of object, and here. Next one, ray diagram. You say ray diagram, right? And here, next one, the position of image. The image position will be, I'll give you one to one. Suppose the object is at an infinite. The position of object is at infinite, you say. That is, the position is infinite. So therefore, there will be a lens ray diagram. Now I am giving the ray diagram for this. Let you take like this. Clear? It is a principal axis and it is a convex lens, or which we can also call it is a convergent lens. So that the image will form, because at an infinite is there, no, therefore image will be formed at a focus point which is in the real, and it is propagated. The rays work goes like this. See, there is no refraction and the rays work goes like this, and it is forms like this. Like this, we'll get the ray diagram will be formation of image. And you remember in this case it is in a real, inverted and diminished at a f. It's not in the big size. You take a very small, or it is a diminished size like this. It is an image position. Here you write real, comma, inverted, and it is diminished in size at f2. This is the first position when the object is at an infinite. And you go for the second. See, second diagram now I am giving. If object is between infinite and 2f is the focal point. See, suppose you take a 2f and infinite like this, your ray diagram will be, it is given like this. Clear? See, same issue. In the previous also I told you related to mirrors. If the object is moving towards the mirror, lens, therefore image also moves away from the lens, which is in the same previous also we discussed. Now there is, you take a 2f it is, and it is f. Here also you take f, and it is also you take a 2f. Now initially the object is at an infinite, therefore image will be at an f2, and it is a real, inverted and diminished size at f2. Now the object is between like this, infinite and 2f. Yes, the position of image also changes from f2 to between 2f and f. The image will be, again it is real and inverted and diminished between f and 2f. Again you draw a ray diagram like which is and which goes like this, and it is forms, the image will be goes like this. Here you say this is the image of position, and here it is real, comma, inverted, comma, diminished in size, and it is between f and 2f, which forms a like this. It is the second position. Of course, now the object position is changed from infinite to 2f. Now you change from this position to 2f, then image will form at a 2f. Again it is real, inverted, and it is a same size, which forms a same size. See, I'll give you the third diagram. If the object position is, if the object at 2f, yes. See, for 2f will be like this. You take, so it is a lens. Now it is, you take a 2f and it is f, it is f and it is, you say 2f. There it is to the object, it is, you say object it is, and the image will be real and the same size. Real, inverted and same size. The rays bar goes through the optic center as well as like this. Therefore, which forms like it is. See, when 2f, at a 2f, therefore image will be also at a 2f. It is a real, comma, inverted and diminished in size. That is, sorry, I am sorry to say same size, equal at 2f. See, this is about a 3, for 3 positions, it is given like this, and you go for the next position. Suppose if the object is at between 2f and f, of course, if I go further between 2f and f, therefore again the image will move from 2f and it is forms between the 2f and infinite. So let us you take a next one. The position of object will be, it is the 4th point. The position of object is between 2f and f. It is the position. Therefore, the ray diagram which shows like this. See, it is a 2f, you say, and it is an f. Yes, this is an object position, and therefore it is f and it is 2f. Now you look at here, very simple. I will tell you one more comparison also. When the object is at an infinite, the image will be diminished and real at a f2. Like the size of the object is moving towards, therefore image also moving away from the lens and the size is increasing. Yes, in the case of when between 2f and f, also it is same, real and enlarged. Little size is increases, maybe it is between the image position between 2f and f. The image position will be, it is real, comma, inverted and it is enlarged between 2f and infinite. Therefore, again you draw a diagram, ray diagrams which passes like this and which may be propagated. Yes, do you want to take like this also? Yes, it is will be like this. Real, inverted and it is enlarged between 2f and f. Clear? Now the next position, actually we started from where? The object at an infinite, no? And gradually it is moving. Now the object is, it is placed at f. Of course, when it is placed at f, therefore the image also move from between 2f to f and it is formed at an infinite, which is enlarged and real, inverted also. So that you draw a 5th position. Now the object position is at f. Clear? You draw a ray diagram will be like this. Yes, it is 2f you take and it is f. There will be a object is like this. Therefore, it is f and it is 2f and which is infinite. So that there it is to be rays goes. Okay, I mean to say like this. Therefore, the image will be enlarged and real, inverted and it is at infinite it is forms. At is infinite it is forms. Because it is at an f, no? Therefore, it is enlarged, real and inverted. See, these cases, you remember, for all these cases, very simple. For all these cases, the image will be real and inverted only, and which is in the sizes are different sizes. When it is till f, when object is moving towards a lens, therefore image also moves away from like this. Let us, I want to tell you another case. If the object is, it is between the focus point and the optic center. Yes, for this case only, the image will be virtual and it is erected and which forms along the same or towards the same object side only. The image will form same side. Clear? Shall I give that? Let us. We will go for the next one. If the object position will be, between focus point and the optic center. You take between the like this. See, now you take the next ray diagram. Alright, so it is optic center and it is in a focus point and it is a 2F. Therefore, the object is placed between F and you write here F and optic center. Of course, the image will be virtual and which is in the same side and enlarged, erected, enlarged on the same side. See, the image will be like this, it forms. Right? You take a ray diagram like this. Okay. Okay, this is the image will be forms like this. See, it is in the, it is same side, image position same side and enlarged and erected and it is same side and it is a virtual. This is very important. A virtual image will form. See, this is only one case in case of a convex lens. The image will be virtual only at a one case. Clear? And this is related to the convex lens. Now, I want to tell you about a concave. Sir, what will happen in case of a concave? Let us about a concave. See, in case of a concave, the image will be virtual and erected images will form. See, you take it positions of like this. Now, the object will be at an infinite, at an infinite. Therefore, you take a concave lens, right. Now, the image will be forms virtual and it is erected and it is diminished at F. The image will be very small, diminished. So, the object position will be like this. You take a diagrams, so which may be convex, right. So, this is will be the image position. You take an object, it is which is going through like this and it may be forms like this. It is a virtual image will form. So, instead of taking this rays, you take only one. So, which forms like this. Clear? It is erected and it is virtual and it is diminished in size. See, when it is object is at an infinite. Suppose when the object is, it is between the focus point and optic center. You say the object position will be between focus and optic center. Yes, you say optic center. So, in this case, yeah, one case will get again, it is a virtual, erected and it is a diminished. Okay, the image will be diminished and it is forms a lens like this. Between this optic center and like this and it is optic center, therefore, the image will be, it is forms like this. So, this is the ray diagram related to virtual, erected and diminished between the F and P. Clear? This is about a concave lens. Okay? And here, I will tell you conclusions. In case of a concave and convex lens, the first one, in case of a convex lens, see, except one position in case of a convex or convergent lens, so the image will be real, inverted, right, but the sizes are different. See, sometimes it is maybe diminished and here same and it is enlarged. And here except one case, no, that except one case is nothing but when the object is between optic center and focal point, therefore, the image will be, it is erected, enlarged and virtual image will form. In case of a convex lens, this is the conclusion related to convex. Whereas a concave lens, say the image will be always, it is a virtual and erected images which forms. Clear? This is about a concave and the convex lenses, the regarding two lenses, the formation of images. Okay? So, if you go through this and it is help you in the further classes. Okay? And coming to the, already we know about a sign conventions also, clear? So the sign conventions also I was given very clear, and if you go through that sign conventions, and it is in the next classes it is help you, right? Let us, I want to tell you another one, that is about a here you take a next one, lens maker's formula. See, it is a lens maker's formula, also we can call lens formula, lens maker's formula. The side heading will be, you take as lens maker's formula, or lens formula also, no problem, right? In this lens maker's formula, you take a one lens, any one lens, either a concave or a convex. Again we should apply a sign convention as usual, we know sign conventions. So let us, you take a, first of all I will explain you theory related to the lens maker's formula. Suppose you take a convex lens, right? There will be a like this, which has a two radius of curvatures and which has a two focal points. You look at the two focal points, it is F and it is F. Suppose the object is position will be at an O like this, and it is an optic center. Very simple concept I will tell you. Now the ray where goes, it is an object distance, you say U, which it is a position is placed at a distance U from the convex lens. Let the image will be forms. See, because of this refracting surface concentrate, see that because of this curved surface there will be a image is forms at a position will be like this. Because of this curved surface, the image at a position you say V. Sir, here one thing, when image is propagating, because of this lens there is a image is formed at an I1, no? This image will passes through the next curved surface, next lens, next refracting surface, isn't it or not? Because this is only formed image, but this image will passes through this next curved surface. Of course this lens also gives the another image. Another image will form because of this image is propagating through this lens. So now this image will act for this lens is as an object. Therefore the position of image will be, you take like this, which is propagating and which maybe forms at a position of I2. You say this position V dash. I think everyone clear. Now the rays were going from one refractive index to another refractive index. See, before only I told you very clear for the refracting surfaces, spherical refracting surfaces, there will be a formula mu2 by image distance, mu1 by object distance, mu2 minus mu1 by r is the formula is there in the spherical surfaces, which already we discussed and already we proved this, right? Now let us, we have to use this relation. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. There are two refractive index of surfaces are there. This is a one medium and it is another medium which propagating the rays were from one medium to another medium. Let us use a first lens. This is the, you say first lens, and it is, you say second lens. Now I am giving for first lens. When the rays are going from this, no, so you take mu2, of course it is propagating from first medium to second medium, and there is a image distance is given as V minus, and here next is object distance is given as U. You don't apply any sign convention, we will see in the final. So mu1 by U is equal to, see, mu2 minus mu1 by the radius of curvature, because there is a radius of curvature is given, you take as a radius of curvature is R1. Right, it is the first one it is. And like a second lens, use second lens. Now the ray actually propagating from this refractive index to this refractive index. So little here we have to say for the second lens, that is we can say mu1, this is here actually this is the image position, no? In this case the image will act as an object, no? So that here we will get, it is we can say mu1 minus, because the position of this one we can take minus, and here mu2 by the, it is will be the V dash. It is in the reverse direction we can take. which is we can take in the reverse direction. I am sorry to say, this is we can take like this, because it is an object image position. No, this is will be the image position, and this is will be the like this. So that mu2 minus mu1 by r2 actually. But the rays are propagating from which medium to which medium? Here it is propagating from 1 to 2, no? You change like this. It is equation 2. Very simple. Very simple in this case. Now let us, you add these two equations, 1 and 2. Add like this, mu2 v minus mu1 by u plus mu1 by v dash minus mu2 by v is equal to mu2 minus mu1 by r1 plus mu1 minus mu2 by r2. Simple, look at here. So whatever it is there is you cancel it, because if it is cancels, then therefore you cancel, make the cancellation. Okay, so that we will get the cancellation will be, here it is will be like this. See, it is v dash. So the first position of image will be, we can take in v dash, no? Just you change your, this is you take a v and it is you take a v dash, so that it is will be v dash. So here we get adding, no? So v dash, and this will be v and v dash. Clear? mu1 by v1, mu1 by v minus mu2 by v. Here also you change little, it is image distance, no? So that you will get like this. Clear? Now you change it like this, therefore this will be cancelled. Then here will get like it is, you take a mu is common, 1 by v minus 1 by u, this is equal to, here look at, actually mu2 minus mu1, and here also mu1 minus mu2 is there, no? In this you take a mu2 minus mu1 if you take a common, therefore it is will be r2. Right? It is actually will get r1 minus r2, because here we are taking mu2 minus mu1, no? Here it is there only mu1 minus mu2. So that will get a like this. So here you take a 1 by v minus 1 by u is equal to mu2 minus mu1 by mu1 into 1 by r1 minus 1 by r2. Is it okay now? Then therefore in this case we can take like this. In this like this we can take 1 by v minus 1 by u is equal to, you take mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. So mu2 by mu1 is nothing but we can take as it is, because propagating from one medium to another medium, no? 2 with respect to 1, or we can also say mu r, or in simple you say mu also, no problem. 1 by v minus 1 by u is equal to mu r minus 1 into 1 by r1 minus 1 by r2. This is the lens maker's formula. This is the lens maker's formula. So that you give as a number, it is 3. So this is about a lens maker's formula. Again we have other important relation also in this. Suppose you take a object is at an infinite, therefore the image will form. See, if object is at an infinite you take, therefore image will form at a focus point. So that here will get what? Here it is you take this, then it is infinite, no? Then 1 by f is equal to mu r minus 1 into, it is 1 by r1 minus 1 by r2. You say equation 4. Now here you replace this mu r minus 1, 1 by r1 minus 1 by r2 is equal to 1 by f. So now from 3 and 4, then the final will get, see final almost I am telling. Look at here, from 3 and 4, 3 and 4, therefore 1 by v minus 1 by u is equal to 1 by f. This is the lens formula. Clear? This is about a lens formula. So this is the lens maker's formula, and here sign convention to be applied. Okay, this is related to lens formula, and we'll see in the next class. And as on this basis again we have other problems also is there. So we will see in the next class. Thank you very much. Thank you.